Now let's try to see how to do all of this in MATLAB or Python. First, we're going to plot this function, and then we're going to solve for the integral, and then we're going to plot the integrated function. We begin with MATLAB. First, let's type in clear, CLC, and CLF, just to clear all variables. Then we define the limits of integration. So let's type in limits of integration. So a equals 0 and b equals 0.8. Next, we defined the range of x with a specific step size. So let's say that the step size is 0.01 and x will be a equals a from a to b with the step size as shown. Okay, so that's your variable x. Next, we solve for the function f. Okay, so f equals 400 times x dot raised to the fifth. If you remember, the purpose of this dot here is to tell MATLAB that this is an array. Okay, and I want this array to be multiplied element by element, and each element will be raised to the fifth power. If you don't have that dot there, then MATLAB will produce an error message saying that it doesn't know what to do with the operation. So the next is minus 900 times x dot raised to the fourth power plus 675 times x dot raised to the third power minus 200 times x dot raised to the second power plus 25 times x plus 0.2. Okay, and then let's say, and then we're going to plot this. So plot x, and then let's change this to fun. Okay, for reasons that will be clear later. Okay. Okay, the next is to solve for the integral. So I equals b minus a times f of 1, okay, plus f of length x divided by 2. And I'm going to explain what this f of 1 means and this f of length x means in a little while. So just finish this code. Next is to plot the trapezoid. Okay, so I'm going to assign that to the variable f1, and this will be equal to, okay, so for I equals 1, 2, length of x, f1 of I, f of 1 plus, so I have this as a numerator, denominator, and then I also need to multiply this to x of I minus a. Okay, so the numerator is f of 1 minus f of length x all over b minus a. So let's check if the parentheses are consistent. So we need one more here. And then I end the for loop. Then I type in hold on, then plot x f1. Okay, hold off. Okay. Okay, let's try to see if this works. Save this first in a folder, and then I'm going to call it trapezoid. So save. Oh, right, that's right. This should be fun. This should be fun. Should be fun as well. Fun. Okay. Okay, and here's the figure. Okay. So here is your function, the original function, and here is the integrated function. Okay, or your segment. Of course, we chose a single segment with a width of 0 to 0.8. In the machine problem, what you're going to do is to choose smaller segments, and for each segment you're going to perform this integral and then add all of those integrals to get the total value of the integral. Okay, so what you can also do is to define a function, okay, which will probably make things easier for you, or probably not. So function y, f of a equals f of a. Okay, so I'm going to copy this. Sorry, let's make this x. I'm going to copy this C, and then put it this here. So y equals. Okay, that's it. If I save it, I have to save it as the same, using the same file name as the function in a file name that's the same as the function. So that's f. Okay, which is f here. So that means that the file name has to be also f. Okay, now I can use that and replace this. So fun equals f of x. And also I can replace this, so let's just put a comment here. Okay, I equals b minus a times f of a plus f of b divided by 2. And I can also do this. F of f1 is equal to f of a plus divided by times x minus a. So the numerator is f of b minus f of a, and the denominator is b minus a. Okay, and if I run that, should also produce the same result. Okay, now what is this and this, and how is it different from this and this? Okay, let's first create an array. So let's first clear the variables CLC. So I'm going to create an array f is equal to 1, 2, 3, 4, 5. Okay, now this array has 5 elements, and if I type in size f, it will show me how many elements, how many rows, and how many columns it has. So it has 1 column and 5 rows. So this is a 1 by 5 matrix. Next, I'm going to type in length of x. This tells you how many elements are inside the array f. Okay, so there are 5 elements in the array f. Now, what if I want to call these numbers? Okay, so just to make it interesting, I'm going to change the numbers. So clear everything, and then CLC, just to make it interesting. I'm going to change that 34 to, and then 8, and then 90. Okay, so then of course the size of f will be 1 by 5, and its length will also be 5. Okay, so I want to call the first element, and in order to do that, I'm going to do this, f1. Okay. So the first element, f1, is 12. So f2 will then be 34. f3 will then be 2, f4 will then be 8, and f5 will then be 90. So f3 is 8, f3 is 2, f4 is 8, and f5 is 90. Okay, so as you can see, if you want to call out each of the elements or any of the elements, this is how you do it. Okay, you call out the function, and then you use the parentheses and write down the index corresponding to where that number is placed. So fun1 means that I'm calling out the first element of the array fun. Okay, and fun length x here. Okay, I'm doing two things here. First, I'm determining length x, which gives me the total number of elements of the array fun. And then if the total number of elements is, for example, 80, and then MATLAB will see this as fun 80, then MATLAB will give me a value, or will give me the last element of the array fun. So this is the first element, and this is the last element. Okay, if you're wondering why I didn't put in the last element value, well, and that's because I can change the step size here, and it changes the size of the variable x, and consequently also the variable fun. Okay, so to generalize, I put in this, okay, so that it gives out the last. It returns the highest index for the variable fun. Okay, now what about this? How is it different from this? Okay, so I've created a function, okay, y is equal to f of x, with this operation. Okay, I don't really need the oh, I might have missed. Yes, that's right. I missed that. Okay, 0.2. So what the function does is to perform this operation. Okay, first it takes in the variable x, performs the operation here, okay, and then returns the output y here. Okay, so if I clear everything here, so clear, CLC, you can see that the function f is already recognized because I'm in the same workspace or same folder. Sorry, here, there, you have the function f there. So if I call on the if I type in f of 0, then what this is doing is that I'm putting 0 here, and then 0 here, 0 here, 0 here, 0 here, 0 here, and it will return 0.2. Okay, as expected. If I put f of 0.8, okay, we know that it's 0.232. Okay, so that's what we have, what we get. So I can call. So by doing this, I am able to call the function, okay, f, and this is what it does. Okay, now it not only works with single digits, but it works also with arrays. So this is why when we go to this function, I have this f of x, where x is an array. Okay, so you can use a single value here, or you can use also an array as an input. But remember, if you want to generalize, you have to put these dots here so that MATLAB will operate on arrays as well as single digits. Okay, so if you run this again, okay, we should be able to get the original function. Okay, now let's do this in Python. Okay, we are going to need a few functions such as arrange and plot. So I'm going to import numpy as np and import matplot lib.pyplot as plt. We'll begin with the limits of integration. So a equals 0, b equals 0.8. Okay, and then we'll go through the range of x with step size. So step size is equal to 0.01 as before. X is equal to np.arrange a, b plus step size and step size. Okay, if you recall, this first this is similar to in MATLAB to defining x equals a to b with the step size of 0.01. But here you use the function or the command arrange, and then this is the minimum value, this is the maximum value, but it's not included, which is why I have to add this step size. Then also this defines the step size from A to B, which in this case I define to be 0.1. Okay, then I can type in fun is equal to f of x. Okay, and then of course I have to plot it. So plot x and fun. Okay, next let's solve for the integral. So I equals b minus a times, okay, f. Okay, now this is how MATLAB is different from Python. Okay, instead of using open close parentheses, we use open close square brackets, f of 0. Also, the first variable has an index of 0 and not 1, okay, in Python. Okay, and then plus f of length x. Okay, now in MATLAB it's length, but in Python it's len. Okay, and also you have to remember that when it returns the value len of x, it returns the number of elements, so I have to subtract this from 1. Okay, now let me just explain why I have to subtract 1 here. Okay, so the idea is if I have this array, so 1, 2, 3, 4, 5, and if I type in f of 0, this will give me the value 1. Type in f of 1, this will give me the second value, second element, which is 2. If I type in f of 3, this will give me the fourth element, which is 4. And if I type in f of 5, this will give me the fifth element, which is 5. Oh, sorry. This should be 4, fifth element. So if I type in f of 5, it will give me an error because there's no sixth element here, right? So this is the reason why I'm typing len x minus 1 here, because I have to factor in or take into account that in Python the first index is 0 and not 1 as compared to MATLAB. Okay, next is I print that value out, so print, and then in order to do that I have to convert it to string, then round it to to 4 decimal places. Okay, and then I plot the trapezoid. So f1 is equal to f of 0 plus, okay, as before, we have this times x minus a, okay, and this is f of len x minus 1 minus f of 0. And this is b minus a, so I hope I got all the parentheses correct. Okay, then I type in plot plt.plot xf1. Okay, in Python you don't need to type in hold on or hold off. It automatically graphs in the same function. So let's check for errors. What is this errors here? Error here, undefined function f. Of course, it's undefined, right? So I'm a little bit advanced. I can just type it here and then put a comment here so that I can use it later. So f equals, or fun equals 400 times x. Okay, this is how you raise x to a certain power with 2 multiply signs. Okay, minus 900 times x raised to the 4th power plus 675 times x raised to the 3rd power minus 200 times x raised to the 2nd power plus 25 times x plus 0.2. Okay, so I think that should be it. This should be fun. This should also be fun. Fun, fun, and fun. Okay, let's see if this works. Okay, there you have the original function and the integrate function using only just one segment. What if you want to use a function? Okay, so let's define a function here. Okay, so we just copy this one, which would make things easier. So, and then I change this to f. Okay, and then I type in return f. Okay, and so I don't have any use for this anymore. Hash. Okay, so fun is equal to x. Okay, so now it works. So this is the value of the integral shown. Okay, and this is how you do it in Python. So it's up to you whether you'd like to use a technique where you define a function, or you just simply straightforward type in the function like it's shown here, or like it's shown in MATLAB, okay, and figure out how to do things down the line.